introduction class, what is data science? Why we need to learn the data science? What is the some applications of data science like that? Data science name in the sense it have the data. So if we want to do anything by using data science technologies, first we need data. To getting data, to collecting data is the big challenge in our data science technologies. This is today's agenda. Let's see. I already told you we need a lot of data to build a model. We want any information, if we want to predict anything, if we want to suggest anything, first we need some data to get the knowledge. How do we get that data? Nowadays, web data, e-commerce, financial transactions, bank credit transactions, some online trading, purchasing, social network. These are the some main domains they are providing data for us. For example, Google process it gives the 20 terabytes data per day. From Facebook, we are getting 60 TB data. Some other e-commerce, eBay, some other web series, web webs, we are getting the. For example, let's see this eBay gives the 6.5 terabytes of users data. Plus, there is a chance to the one some more 50 TB data like this. So we have a lot of webs to provide the data. So it's not a problem. But
Ma'am, one question I have.
yeah,
Here we are looking into the data science, right? There are some other roles also. Means data science is means closely related to the data scientist profession, right?
yes,
So there are some other professions also, means data analyst, and means how they are differentiate, means is there any totally different work, or they have the similar
yeah.
data science
Uh,
and data analytics?
we'll let you, Akash. First, there are the three difference. One is the data management, then after data analyzing, then after data sciences. Data engineering means they will manage, they will migrate the data into the databases. For example, if we have, let's assume if we have the one product server. So
Okay.
some clients are using that server. So whenever they use that server, automatically data will generate. The data management team, those people maintain entire data in tables by using whatever the database management provides. If they provides SQL, MongoDB, or other Elasticsearch, just data management team, they will collect the data and they will store it into the databases. That's the data management. If anybody want to use that data, they will provide some accesses for the reading of accesses. If some people want to execute some store procedures on database, so based on our requirement, based on the management protocols, they will provide some pipelines to us to using the data. That's the data management team work. Data
Okay.
engineering, we call it as the data engineering. So data engineering. Coming to the data science, there is the two types. One is the data analytics, another one is the data scientist. Data
Okay.
analytics means, for example, if we have the some table data, e-commerce data. Let's assume we have the e-commerce data.
Mm-hmm.
But if we want to know which product most of the people are searching for the which product, most of the people which type of products they are buying very highly, which type of products people won't buy, how much, for example, they we have the one product some, but no people shows any interest on that product. So it is also good information. Why? Because they won't concentrate on that product, they will concentrate the product, which product attracts more users, more people. So this type of information, by seeing the data we can't get that type of information. For example, if it is the 100 records, it's easy to find the which product most people buys, which product they want interest on that product, like that. But if we take it Meesho or Flipkart, 1 lakh or 2 lakh people are using every day. For 10 days, we will get 10 lakh records. Shall we able to get that this type of information through the data? No, at that time, data analyst will be useful. For example, they will provide some graphs, for example, some visualizations in which are useful for the business analytics, business performance, business growth, or to predict in the future future things. If you they if, for example, if we have the shortage on some particular product, if we are able to show that information through graph, they will order that product. Okay. So
Okay.
at this point, data analytics will, for example, let's assume we have the product, we will get the IIS logs. Do you know people IIS logs data? IIS logs means whenever we use one service, it will automatically records to the which operating system we used, from which IP we connected to that server, what is the browse, which browser, for whether it is Google, Firefox, like that, and
Mhm.
how much data we downloaded, how much data we sent. Like this information, whenever service you used, this information will be recorded. Whenever you hit on that service, for each and every hit, there is be one record. Okay.
Okay.
If service goes slow at the particular time,
Mhm.
directly data scientist won't predict at what time it will be go slow and what is the reason behind that. But at that time, and data scientists are different. But data analytics work is they need to analyze the data through the graphs. For example, if there is a performance issue, they need to check what is the inbound at that time. Maybe there is if some user downloads some data very highly, if some user uploads data very highly, at that time there is a chance to perform slowly service.
Okay.
So if we need to, a data analyst will do that type of analysis by using visualization.
Okay.
Yeah, for example, if we have the some product, if the mostly some products based on the country also they will provide some products. So
Correct.
for example, Amazon, for Meesho may be related to the India. Let's assume Amazon, uh, all countries, most of the countries will use Amazon services. If they want to know about the from which country we are getting highest request, like
Mhm.
that type of visualization,
Yeah.
that will also very useful. For example, if they are providing services for the all countries equally, but some countries are not using this service much, but some other countries they are frequently using this service very high. What will they do? If we want to manage high concurrent users, we need to provide extra RAM or CPU, everything to that service. Why? Because people, if the service loads within seconds, people will show interest to use that service. If the service is very slow, the concurrent users will, there is a chance to reduce the concurrent users. That's why what they will do, they will take some RAM from the countries which are not showing that much interest. They will provide high RAM for the countries who are showing high interest. So these type of visualization, for example, sometimes due to this visualization, we are able to increase business market also. For example, based on this season, if we are able, uh, some Christmas season, most of the people buy some cloth.
Mhm.
So if there is a Santa gifts, there is a chance for high demand for the gifts and dresses. Is it right? In some
Yeah.
countries. So based on that, for example, since 5 years, there is a gradual increase. If we are able to show that graph to them, for example, let's take the 2020, 20 to 21, there is the 10% increase. 20 to 20, 21 to 22, there is a 15%. If they are able to get some information like this, they will produce the products based on the demand. For example, there is the 1 lakh gifts every time they will produces, but they don't know this year maybe they will get a high demand. If they will manufacture only those 1 lakh gifts, what will happen whenever customer comes, they need to say, Sorry sir, we don't have stock." What will happen?
Yeah.
Business will, there is a chance to grow business, but we are not able to grow that business. So by using data analyzed information, this type of information, they will show this type of information through the graph. Okay, this is the data analyst job. Coming to the
Okay.
data scientist job is, for example, based on the data analyst, they will know what are the important features for this product. We are able to understand data while analyzing the data. Coming to the data side, they will build models. For example, let's say same take the same case. You can take demand. What is the demand every month to the some particular product? For example, let's assume we have the 5 years data. How much products they sell every month? We have that data. So by using this data scientist will build one time series model.
Okay.
Okay. After building this time series model, if we provide the past data, it will show what is the demand of the next 6 weeks or 6 months or 1 year. Which type of prospect we want to see. It will give the predictions in that prospect. For example, let's see, take same case. Based on the, let's take Diwali, is the seasonal demand. The
Ye-
what are the crackers we are using? Only will use for the Diwali. At
Yeah.
Diwali season only we will get the high demand. In remaining time, some people will use based on their functions, based on their interest. But
Yeah.
demand is very less. If we want to see the type of seasonal effects, this time series forecasting gives the S. For example, if we had a some products, maybe there is a chance to the actually we will get the festivals or something based on the months. So it automatically time forecasting model shows, yeah, this month we have this festival. Due to that reason, maybe these product will get high demand. We won't get same product won't get demand for the all festivals. Based on the festival, products will change. There is a chance for that also. These type of predictions time series models will give.
Okay.
Let's come to the another one. For example, you can take the stock market. In
Okay.
stock market, we have the based on the opening price, we need to predict the close price. So by using data analyst, he is able to say today is the buy sell, day after before is the sell signal. Just like that, they are able to analyze the what is the existing data. Whenever new data comes, they won't say anything whether this data is belongs to that one, that group, this data belongs to this group, like that. That work will able to do data scientist by building the models.
Okay.
Yeah, that is the data analyst. For example, if we have the houses data, for example, let's take bank data also. We have the bank, the people's data who are came for the to take the loan. We have the 1 lakh records. If by using that data, if we build one model, whenever new customer comes, if we provide new customer data to that model, it will suggest directly, yes, you can provide loan to this customer. If this model observes any differentiation, if he is not able to, if any condition fails, that model directly says no, don't provide loan to this customer, he is the fraud.
Okay.
Yeah, it will predict like that. But by using data analyzation, just we can able to say we have the 1 lakh customers. Out of these 1 lakh customers, 80 customers are get the loan, 20 customers did not get loan. We are able to say that type of information by using data analysis. By
Okay.
using data science, we can say whenever new customer comes, we are able to say, yes, this customer is the good customer, you can provide loan to this customer, like that. That's the
Okay.
difference between data analysis and data science.
Okay. Yeah.
But who have knowledge about the data science, these people will exist in both scenarios, data science and data analysis, based on the management require. In
Okay.
some fields, they are enough with the data analysis. They don't need any models. Maybe if they have any services, if they will give this work. So we need to prepare to do whatever our management wants. I think I don't need to explain this this PPT, this slide. I already explained. Just will say,
Yeah.
yeah, an area that manages, manipulates, extracts, interrupts knowledge from the amounts of data. That's the what data science doing. If we have the lot of data, we will manipulate that data to extract the useful information to the business goal. To achieve the business goal, what is if there is any meaningful or important information exist in that huge data, will show that is the very easily to understand without searching each and every record. Our data science will give the insight within seconds, within minutes. So, for example, let's say if we want to analyze data, for example, let's say we have the within 1 month, if we have the Diwali festival, the product manufacturer wants to know which crackers will get high demand. If we want to analyze past data,
Okay.
how many people will require to analyze the data? Is it possible to look each and every record which is the available previous data to find the which product will high demand? At that time, our data science will be useful. It will reduce manpower. It gives the accurate results also like that. For
Okay.
example, in this data science, we'll use three concepts. One is the computer science, another one is the mathematics, third one is the statistics. Coming to the computer science, there is the pattern recognition. For example, let's take C, Java, and Python. Python technology related files will be have some different terminology compared to Java and Python. C plus, okay. There is a
Okay.
some terminal there everyone. For example, the packages which are used in C, Java, Python may be different. So those terminology also very different. Based on that terminology, this pattern recognition will model will group the which are have the similar terminology. So whenever new data comes, if we give this new data to the model, it will say this file is belongs to C plus, this file is belong to Java, or this file is belong to Python.
Python. Okay.
Yes, like that. If we don't know whether it is C plus Java or Python, sometimes we don't know. For example, we don't know how many groups presented in those files. We can't say there are the three different terminologies only. Maybe there is a chance to six. If we don't know that information, then at that time also this pattern recognition or clustering models will able to cluster the based on the terminology. Entire data, it will cluster to the based on the terminology. Visualization is comes under data analysis. Data warehousing means this is data engineering. For example, some databases will works effectively with machine learning. Not machine learning, just the fetching data is main important for the data science. If we want to, if it takes a lot of time to fetch the data, so model building, everything will be goes very slow.
Okay.
Data warehousing comes under the data maintenance. For example, we have the bank customers profile data and their transaction data and their how many times they have taken loan, that type of data in three different files. Okay, but
Mhm.
if we want to build model, these three files information we need. Data warehousing in this part, the DB team, data engineering team will do. They will combine these three information. They will provide our data to us.
Okay.
So at that time, by using the data, we'll do whatever we want.
Okay.
And for example, sometimes we need to find high performance computing. For example, if we have that, for example, let's take Google, Amazon. These are providing different services, a lot of services. They are not providing a single service. Out of those services, we need to check every time what is the performance of each services. No, but it's not easy to observe each service manually. So at the time also our data science will useful to build some models to check the performance. Like this, for example, some mathematical models, statistical probability, and for example, if we want to build this pattern recognition or high performance models, we need to use mathematical and statistical computation to build the model. We'll say what is that. For example, let's take here. What will happen in mathematics if, for example, let's take some formula y equal to a plus b plus c. This is the mathematical equation. What we need, if we want to know about the y, we need to know about the a, b, c values.
Correct.
What will happen if we provide input x as a value, b value, c value? We'll write one program y equal to a plus b plus c. We'll write code script like that. We'll provide these ABC values to this script. It will provide the output. Okay.
Okay.
So this is what happening to build a model. So to build a model, we need these mathematical modeling and statistical and probability equations. They will use those mathematical statistical concepts to build the model.
Okay.
Everyone, some people have some idea. Yes, data science, if we are able to know data science, if we learn data science, we are able to work on machine learning, artificial intelligence. So many people uh, things like this only. AI is sub part of the data science, but it's not a real thing. AI is the main part. Artificial intelligence is the huge part. Everything, whatever exists in this universe, comes under the AI, artificial intelligence. What is
Okay.
artificial intelligence? For example, let's say sensor. If in some Mars, everything, there are some sensors. If we have the lights also, where whenever a sensor observes some human being enter into the room, automatically light will be glow. That is also one sensor. But how do that sensor know whether he is a human being or other? If we want to program whenever a human or any other, whether it is male, female, children, you need to glow the light. If we want to programming like that, we need the machine learning models.
Okay.
Yeah, if we want to recognize language, we need to give some sentences, some pattern, some sentences with language. Automatically, if we build model, whenever new sentence come, it automatically predicts whether it is related to the France or Germany or English automatically. If we want to do that one, we need the machine learning models. These are the some machine learning models. Text mining, time series, recommendation engine, deep learning, basic. For example, we will say about the each and every model later. This is just you people need to know. Art machine learning is the one part under the artificial intelligence.
Okay.
Okay.
So
If we want to, yeah, if we want to solve any artificial intelligence problem, we'll use these machine learning concepts. For example, let's take one machine learning model. Whatever you want, time series forecasting, anything. If we want a prediction, what I said, if we have the different more different technologies related files, we need to cluster same technology related files. That is one. Another one is whether a bank, when whether a new customer comes, whether he is able to clear loan or whether he is eligible to take loan or not. If we want to build that models, we need to use data science concepts. For example, let's take the same bank details. Based on the for example, some customer whoever come, he has the same age, who are eligible for the loan, he have the same gender, he have the same salary. How do we differentiate this customer is related to the customer who is eligible for loan or not? For the for the mathematical equations, we'll provide input to the program, it will give the output. For to build the machine learning models, we'll provide input and output to build the model. Whenever, for example, we'll build model and we'll build the program. Whenever new input comes, at that time, this represented model, what we build in this machine learning, it will be gives the output. It will predict output. First, if we want to build model, we'll use these input output as the inputs for the to build a model. Whenever new input comes at that time, this model will predict what is the output. This is the concept behind the machine learning. Okay. In this machine learning, we have the different technologies. Most of the one is the regression, clustering, classification, association analysis, anomaly detection, recommendation engine, deep learning, time series forecasting, text mining, feature selection. These are the some models we frequently use it. We'll explain each and every model in next sessions. What is regression? How do we build a regression model? How do we predict whenever new input comes? How do we predict output by using this regression model? Like this, we'll explain about the each and every model in next sessions.
Okay, ma'am, one doubt I have. So the models which we are seeing right now, it is already predefined. Just we have to use it and customize and give the input in our require based on our requirement, right?
Yes.
Okay, okay, that's it.
Yeah. Data scientists are the key to realizing the opportunity presented by the big data. The, to bring structure to it for compiling patterns in it. Big data means, for example, let's take the e-commerce data. Bank data, maybe there is some limitation to the, maybe we will get only 500 GB or almost 700 GB. But coming to the e-commerce data, the data will be in terabytes. But at that situation also our data science models will work. If we get that data in terabytes, at that situation, at that big data also our data science model will be useful to get the more useful informative insights. Let's see where we use this data science. Uh, don't take this domain only have high opportunity for the data science. Each and every health care, engineering, business analytics, cyber security, bank, financial, mutual funds, pharmaceutical, in all domains this data science concept will be useful. So you will get a lot of opportunities to get the job or to get to improving your knowledge, everything.
Mhm.
Mostly which type of concepts we use means, for example, mathematical and statistics. These two concepts will be useful to build model. Most of the people will use Python, SAS, SQL. These three languages to build the model. Data mining. This is the important thing. We have the data. We have the case study to solve the problem. But if we don't know the data, we can't do anything. We can't do model build also. If we build model by without any knowledge of the data, it gives only very less results, less accuracy. First, data mining and data understanding is the big. Data mining means data collection. If we collect garbage data, it will give garbage output. If we collect more informative data, then it gives results very accurately. And in which databases we are storing this data? That's what I said. If we want to build model, we need some information, but that information is not available in single files. That information is available in different files. What will happen? It takes lot of time to merge. For example, let's take, I know very well about the Elasticsearch and SQL. If I joined in this company, but these people don't have the SQL database Elasticsearch. They have the only MongoDB databases. If I don't know how to query MongoDB, so it become very difficult to build models.
Okay.
So at this point, data engineering will be useful. They will provide data in what manner we want. They will maintain data in some databases, and they will manipulate data in which point or how do we want. They will provide data. So by using that data, we'll build machine learning models and we'll discover what are the patterns are available in that data, what are the some information available in that data, everything.
Okay.
For example, let's take data science process, data exploration, model evaluation. In data science process, first we need to explore data. Then after we need to build model. Then after we need to evaluate model, how it works. This is the basic process. First we need to collect data. Then after we need to explore the data. What are the some features available on data? Which features are useful to build model? Which features are don't have that much information to build a model. So we need to explore data like this. Then after we need to build model and we need to check our evaluation how the model is working, whether it gives good results, good predictions, or whether it gives any mismatches. We need to evaluate in that point. By using this data science, these are the some models we will build. Decision. These are the some classification models: decision rule introduction, k nearest neighbor, naive Bayes, artificial neural networks, SVM, support vector machines, ensemble lens. Ensemble lens means random forest are those. Under regression, we'll get the linear regression, logistic regression. If we want to build regression model with SVM, there is a chance in Python also. How do we build regression model or classification model using each and every concept? For example, support here decision tree and the support vector mission. Both concept will be useful to build a model. But whether while building model, this support vector mission will use some concepts, maybe statistics concepts. In decision tree, it will take some other probability concepts to build a model. We don't know which concept will work on the existable data. We need to check by building each and every model, which model gives high accuracy, we'll finalize that model.
Okay.
Okay, by seeing data we won't get knowledge. Yes, this data will use decision tree model will fit on this data, or whether SVM will fit on this data, whether linear regression will fit on this data. We won't say like that by seeing the data. So we need to check everything. So
Okay.
we'll explain what are the concepts behind each model. Regression models are the linear logistic association analysis means, for example, these are the rules. Based on the rules, it will, for example, let's take e-commerce only. The one who buy milk powder and milk in e-commerce site, we will recommend to them based on the previous purchase milk powder. Will recommend to him diapers. If for example, let's take the people who have a baby, then those people will buy milk powder. Is it? Through that sense, we'll suggest diapers to them. So if they require, automatically they will buy. If they don't have require, but if they need that require next month, so whenever we recommend, yeah, we have the it will be useful next month also. Why we need wait till the next one? If we buy this one now, it will be will store for the to use the next month. By thinking like this, automatically the buyer will definitely buy that product. This is the what concept most of the e-commerce sites will use. So if we want, based on those rules, if we want to do that type of recommendation, this association analysis will be useful. Okay. Coming to the clustering. Clustering means we have the lot of files, but we don't know how whether those are all files coming related to this similar technology, or those all files related to the different technologies. If we don't know, this K means DB scan self organizational maps. These three concepts will be useful to cluster those files based on the terminology, or based on the meaning of the each text available in that file. For example, if we have the different sweets, all are sweets, but different sweets. Based on the ingredients used to manufacture that sweet, it will cluster all the all the sweets related to the laddu, all the sweets related to the some other products like that. Okay, all are sweets, but different sweets like that. For example, we have if we have the library, like in that library we have the 1 lakh files. Okay, but people, books will become old based on the day by day it will become older. There is a chance to lose some papers through the books. That's why most of the people will store files on the some databases in computer database. After some time, due to some fire accident, they lost all the books whatever the available in that library, but we have the files, but we don't know which file related to the maths subject, which file related to the physics, which file related to the psychology. At that point of view, this clustering model will be useful to cluster the similar. For example, psychology terminology is different for the maths terminology. So based on that terminology, it will group all math files into the one group, all psychology files into the another group, like this. Okay, if we want to solve that type of problems, it will be useful. So these are related to the file. Common applications means test mining, time series forecasting, anomaly detection, feature selection. For example, test mining means, you know, text generation concept. Did you know? Text generation means, for example, we have the one C plus script. We build some store procedure to manipulate the data from one format to the another format. Sometimes it will take, if there is any syntax error in that script, sometimes it will take 1 or 2 days to identify that problem. I think you people are faced or not, I don't know. I heard about it from 4 to 5 people in my working place. Anu, I spent more than 2 days to identify that I have put one full stop, one semicolon instead of colon in my program. Due to that, it throws lot of errors. So at that time, if we give basic structure, automatically this text mining fill the entire code. For example, if we give the if function, let's take in our Python program, after if function, we need to put semicolon. Okay.
Okay.
If we want to concentrate on those semicolons, colons, it will take some, it will waste some time. This text mining will generate those type of tests also. If, for example, sometime they will give one concept. For example, you know, essay writing. Everyone know essay writing.
Yeah.
They will
Yes.
give one concept about the essay writing, but it's very hard to write the 1 or 2 papers. If we know only we have the some knowledge, very little knowledge. If whatever knowledge we have, we will write that test. Then after, if we give the test to the test generation model, it will automatically generate some text related to the what are the concept we provided to that model. That is the one type of test mining. uh, Another one is the test classification. Test classification means, if we have the one file have the different languages, in same file we have the different languages, it automatically classify the text based on the language. Whatever, for example, we have the text, we want to identify entities. For example, let's take the organization, places, human being names, what we call date, email IDs, phone numbers. These are the entities. If we
Mhm.
provide data to the model, it automatically identify the all entities. That is the one of the test mining NLP project. These are
Okay.
all some common applications for our time series means these stock market. They will use time series forecasting. And this one, e-commerce, they will use time series forecasting based on the they will use this time series forecasting to know about the product demand. So based on this time series forecasting prediction, if it says there is a chance to a 1 lakh products order, if it will predict the demand like that, they will manufacture products based on their demand. So at that point also this time series forecasting useful. Anomaly detection, it will be useful all domains. Whenever bank, if we have the bank customers data, if is there any fraudulent, we need to identify those fraud. Anomaly detection. Coming to the some other military applications. In military applications also these anomaly detection will be useful. Okay. So
Okay.
we have, for example, let's take the financial. Uh, Financials, there are different finance. One is for the customers, regular, common people, middle class people. Some financial related to the business people. We need to find anomaly on the business people. For example, the middle class people will take loan only for the 1 lakh, 2 lakh. Maybe if they buy a house or anything, they will apply loan for the below 1 crore. But coming to the business people, they will apply loan for the crores, more than 1 crore. If is there any one anomaly, one fraud customer comes to the bank or financial institute, if they provide loan for them, it will it is very effective to that financial institute or bank. If they will lose their entire money. So at that point also these anomaly detection will be useful like that. We have a lot of applications. I mentioned only some of those. So don't worry, this data science will be useful. Some technologies, those are useful for the in some domains only, but our data science will useful for the all domains in banking, financial, stock market, whether pharmaceutical,
Mm-hmm.
healthcare, anywhere. Uh, Anybody have any doubts about the data science program, data science concept?
Yeah, ma'am, one doubt I have here, not here, but in the present slide, which we are looking right now,
Okay.
the classification and all. Yeah,
Mm.
again, next, yes, yes. So in the this first one, there's the process basics. So here we have collected the data, right?
Yes.
So we have the data now. We have stored somewhere. Now we have to use as per the model. So here the
Yes.
model is the classification which are written here in decision tree and all this up to ensemble learners. So we have to take the data and use we have to use it each and every classification, and then whichever the classification it gives us the best result, we have to go with that classification.
Yes.
Is it? Okay.
But see, for the starting, you don't know based on the case study, based on the data, you don't know which model will be useful. But if you worked on this data science till 3 4 years, so you will see lot of different data, you will build lot of different models on those data. So at that time you will also get some knowledge. So for this case study, for this data, maybe these models will work effectively compared
Okay.
to other models. You will get based on the, if you work on that models, you work on this data science models, you will get slowly that knowledge also.
Okay. Okay. Which will be
but
the
but
appropriate
at that
model?
point also you will get some knowledge. First you will build which, if for example let's say based on the case study, this is the bank fraud detection. So whether it is yes or no, whether the new customer, whether he is eligible for the loan, whether he is not eligible for the loan. So it comes under the classification model. So you don't try these models, you will need to try these models only. You will get that knowledge. We'll provide how to we get, for based on the case study, how to we select models, will get that information in next sessions.
Okay.
Okay. But in these models, based on the data, you will get maybe these two models will give good results on this data. You will try those models. If those models get gives good results, then fine. If those models did not give good results, at that time you again need to check other models also,
Okay.
till the time till the you reach the expected goal.
Mm-hmm.
We need to change different data pre-processing, the different models, till we need the tool, we need the acceptable accuracy.
Okay.
Some clients okay with a 90%, some clients need 95%, but don't expect 100% predictions from the data science models. Why? Because
Okay.
these are the predictions. Just we are predicting this is maybe related to that one. We can't say 100%. Maybe there is a chance for the 98% accuracy, but data science models won't predict on the 100%.
Okay.
Yes, on complex, whether it is very simple problem, maybe there is chance to predict 100%, but you won't say, no one say data science model predicting 100%. Why? Because if there is any difference in whether whenever new data comes, if there is any difference whatever the data we used to train the model, it will automatically predict wrongly. We
Yeah.
don't know what is the upcoming data. We know about the only old data. So sometimes we need to rebuild our model with the new data also. For example, let's take time series forecasting. Based on the last 5 years data, I have predicted next 1 year how is the every month how demand will go. If after 1 year, if we want to build next year data, we need to rebuild our model using existing year data.
Mm-hmm.
That's what. For example, let's take the demand of the e-commerce this 2023. This is the sixth month. I have to build more time series model this month. So I have predicted what is the demand for the next 6 months. Okay. After
Okay.
6 months, January 1st, if I build, I predicted what is the demand from 2024 6th to June. The model won't give that much accuracy on the existing data. We need to rebuild model by using these 6 months data, July to December.
Okay.
Yeah, why? Because there is some, for example, due to some reasons, the from last 5 years, increment is only 10%. Every month, the demand increases 10%, 8%, 15%. Maybe some reasons, the demand increases very highly till 20%, 25% in these 6 months. Okay. If we did not rebuild at the end of this year, it will our model will predict maybe there is a chance of the demand only 10%, 15% only. Why? Because this model don't know about this drastical increase in between the July to December. Why? Because we did not use this data to build the model. If due to lack of this information, it will predict only 10 to 15% increase on the demand. So
Okay.
sometimes we need to rebuild model based on the case study. Which type of problem this model will solve. Based on the case study, we need to rebuild model. This is the what is the data science. We'll explain about the what you said, sample data, population data, how do we collect data, what are the different approaches we use to collect data. Everything will comes under next session.
Okay. So, ma'am, is it possible that means we can create our own analysis of data analysis means by our own do means a person means let's say example of a web development of a full stack development, right? So what they do is they have the tools, they have the VS code, they have IDs, and they look into the project and they build one dummy project to showcase to the companies, to the recruiters. So is it possible in this domain, in this data science domain, to build a dummy project and to showcase somewhere? Is it possible?
Yes, it's possible. We'll explain how to build by using dummy data set, how to build model, how to solve problems for the each and every model in this session. For
Oh,
example, whenever I thought this decision tree model, there are the two sessions for the each model. In first session, we'll explain what is the concept behind that model. How do we build model? What theoretical concept? In second session, we'll explain through the Python how to build that model. will provide one dummy data set. By using that dummy data set, we'll build one model, decision tree model. Will show you how is the result, how this
Okay.
model gives how much percent accuracy, how much percent. If for example, whenever we build a model, it gives the 50% or 60% accuracy. We'll explain how to improve that accuracy also.
Okay.
Yeah. So each and every model have the two sessions. In one session, we'll explain about the theoretical concept. In second session, we'll show how to build models through the Jupyter Notebook. Jupyter Notebook is nothing but Python.
Yeah. Yeah. Okay. Yeah.
Yeah.
Yeah. That's it, man.
Okay. Anybody have any doubts?